Good morning, Dr. Elaine. The following is from Chapter 10, number 16, and the scenario was two objects are colliding with given properties of mass and initial momentum for object A, and mass of object B, and the final momentum of object B. We are not told what type of collision it is. We are just given these properties. We're told to find momentum, the final and total momentum for both objects, then the total momentum, and the final kinetic energy. And then we have to infer from that if the collision is inelastic or elastic. So for the first one, it tells us to find the initial momentum for object A, which is just pi equals the initial object for momentum A plus the initial object for momentum B. And both of these values were given, so you just solve. You get 21, 1, and 0 kilograms per meter per second. The second one, it was asking for the final momentum of object B. So the final momentum is, momentum is a law of conservation. Left linear momentum, you can do PAI equals PBI. Sorry, PAI equals PV, and you can break it. You can simplify it to this. Afterwards, you just solve for PBF, which is the final momentum. All these values were given from part A, and what they already gave. All right, for part C, I was asking for initial kinetic energy of object A. So I use Ki equals PA squared over 2ma. So I first found the magnitude of PA, which is right here. Afterwards, the square root goes away, as it says that PA is squared, and you get the value of 22.5 joules, and that's for object A. The second one, same scenario, but use object B. So all these values were given once again, and the units do match, and you get 2.36 joules. Alrighty, for part E, the final kinetic energy of object A. This was given in the original equation. I just wanted to convert it to magnitude, which we did right there. And the units, since it is energy, they should be in joules. For F, KF for object B, same scenario once again. The units were given. I think they just did this just to help us guide through the next couple of steps. So kinetic energy of object of the system. So I did Ki equals Ki plus Kbi, which is kinetic energy is equal to the initial for both, and we get 24.79 joules. Once again, Kai and Kbi were given in part C and part D. The final kinetic energy, same thing, Kf equals Kf object B plus A plus B. We get 15.80. So this is where they were asking if it's elastic or inelastic. Well, something along those lines. I said that since energy is the initial energy is not equal to the final energy, it is not constant. It is not an elastic collision. It's inelastic. This happens because of the increase of temperature and internal energy transfer. So delta E, which is change in energy, is equal to the initial minus the final, and I got 8.99 joules. If the initial and final were equal, then they would be it would be elastic collision. And lastly, they were asking what are some of the criteria that I should assume to solve the problem. I said energy flow due to the temperature difference between the system and surroundings is negligible. I assume this because the time interval is very small, and that was about it. So mostly from this section, I think it wanted us to find the energies and to determine if it was elastic or inelastic collision. If it's elastic, momentum and energy is conserved. If it's inelastic, the kinetic energy is not conserved. So I believe that's all. So thank you.